that we haven't had anybody call in with the answer to the brain teaser either. So we got 2 prizes today, so let's get busy. All right, well, I see we got some stuff here. Do you want to talk about a little bit about what that might be?
Absolutely. Well, actually, ma'am, would it be all right if I made one statement on the secret word?
Yes.
Well, just want to make sure everybody keeps in mind, Pluto is not a planet.
Oh,
Yeah.
yes. Yeah. Poor thing got kicked out, didn't he?
Good thinking.
Good reminder. Yeah, all righty.
Well, yes, ma'am. Matter of fact, Sean, would you like to explain a little bit about the hybrid rocket we were talking about?
Normally you think about rockets, you think about fire, it's like you see the big rockets on television. This is basically a smaller example of that. It's like, this doesn't really look like something you'd normally burn though. This looks like something, you know, you'd see in a windshield, or I don't know, a basketball hoop. Doesn't look like it burned very well. But instead, it's actually plexiglass, which is, you know, backboards, which is, you know, when you think about a backboard, if you were using that, you don't want it burning up. So what we do to make it into a motor is that it's like we put pure oxygen through it. And when we happen to do that, it's like we ignite it, we burn it, and it starts burning because oxygen burns really, really well. And it's like we use this module over here to, it's like, can you make sure that doesn't fall? It's like we use this because it's pretty neat. So this is what it looks like when we haven't fired it yet.
So
like,
this is
the later version of that.
Okay, all right.
Unfortunately, we can't fire it today in here because of safety concerns. But at Cool Science Festival,
Yes, sir.
Yeah.
it's like that will happen there. So make sure to come out for that because then you can actually see it live.
All right.
And that's going to be pretty cool because I always love firing that personally.
And so this is the result after that's been fired.
Mm-hmm.
Okay.
So I'm looking at this here. I don't know if they can see it, but it looks like it's very small in there, all the way through. But when you look at the other ones here, it looks like you lost a whole bunch.
Yeah, that's what happens when we burn it. It's like you can see, it's like it produces this, it's like if you look at it, it looks like the walls are touching if you look at it closely. It looks like we burned all the way through. But in reality, it's like if you look at the end, you can see we're not even close to burning all the way through. It's an interesting optical illusion. It's also how we know when to stop firing it. Because if we don't, normally it's like we put a safety shield around it, but that's just a safety thing. We don't want to burn all the way through because that makes a mess.
We're very safety conscious. So.
Yes, you have to
You
be
have to
whenever you're doing any type of science, right? Well, you know what?
We
Tom,
have
I
a secret
think
word
we have
winner.
a winner. You want
We
to
do.
talk to him?
Joseph, are you there?
Yeah.
And what is our answer to our secret word? Let me read the secret word question again, and you can tell me the answer. What is the second smallest planet in the solar system?
Mars.
Mars.
All right. Did you know that
Nice.
yourself?
No, I looked it up.
Good for you.
Good research.
Good for you. And now we have space
Well, let's go ahead.
exploration going to Mars?
Yeah, well, let's make sure we tell him that
Oh,
he's
yes.
won a
I
prize,
forgot.
right? Yeah, so we want to thank you so much for calling in because you're going to get 2 extra value meals from McDonald's. Well, you don't get those. You get a certificate, and then you have to go to McDonald's and get your prize, okay? So
All right.
thank you for calling in. We were worried we weren't going to have a winner, so thanks a lot.
Huh?
All right, Tom.
All right, and then we have explorations going up to Mars now through NASA?
Oh, yes, sir. Absolutely.
Do you guys have anything to do with that, or?
Well, since we're still undergraduate students, unfortunately, we can't be working on any really big projects. We do, however, do research on a lot of the projects that go. So, for example, just this past semester, so that's in the spring, I did a research project on using asteroids as a method to get to Mars. Wow. And you can significantly reduce your fuel requirements by doing that. That said, we do have our own space missions. We actually built, design, test, build, and operate our own spacecraft at the Academy. And both Sean and I, in fact, Sean has his flight suit on so you can see, our space operators that work there at the Academy.
Nice.
So you build your own,
Yes, ma'am.
and do you, where do you send it off at? From the Academy?
Oh, I wish, man.
Oh, yeah, that would be great.
That
So,
would make for a great aero demonstration.
so where do you ship it? Do you get to go with it to see it be,
Launched?
yeah.
Absolutely. We're currently building FalconSat 6, so our
Okay.
6th satellite. That's been put into an orbit. We've also done a lot of non-orbiting missions, so we've done high altitude weather balloons, and we have some of that equipment here. We've been able to put some payloads on the space shuttle, and those were really cool as well. But FalconSat 6 is the sixth independent satellite. That'll be launching out of Cape Canaveral, and it will be launching in May of 2016. And to test it, it's a huge effort. And we go to Kirtland Air Force Base and Edwards to make sure all the components will work correctly. And the experiments we get from the Air Force Research Lab and the Space and Atmospheric Research Center. That is our physics department at the Academy, and they need experiments in space. We need money to put experiments in space, so
Yes.
it's a great trade.
Yeah. Well, then, since you're close to graduating, your senior year, like doctors and dentists and so forth, they're actually out, in an office or so forth, a hospital actually working. Are you still a lot in the classroom as a senior?
Yes, ma'am. Yes,
Okay.
ma'am. I have a satellite communications class, spacecraft attitude dynamics, a English class, and then I also have capstone. So the academic classes we're still doing, but then I also have, like you said, a practicum. So I'm responsible for the test and operations protocols of the satellite. So when we take it to Kirtland Air Force Base, for example, rockets are very shaky environments, and we need to make sure the satellite can survive that on its way up. So they have a big shaker.
Oh, yeah, to test it.
Exactly, and so me and my team, we are responsible for setting up what exactly that test is going to look like and making sure it's executed properly, things like that.
All right.
Sounds good.
Well, you know what?
I think you brought a video along.
Yeah.
Oh yes.
Yeah.
So what's on this video you brought? I think we're going to show it here in a second.
Well, the hybrid rocket that Sean mentioned, we fired it in front of a group of Boy Scouts at our astronautics laboratory. So hopefully that can be cool.
All right.
Sure it
let's,
is.
Let's see what's going on. All right.
Oh, nice.
That's good.
You call it a hybrid rocket. What do you mean by a hybrid rocket?
Well, Sean.
Well, most rockets, like the space shuttle, has two types of rockets. One, it's liquids. It's like you're burning hydrogen and oxygen together. And then you have the solid fuel, which are the smaller ones on the outside. And they are it's a solid is literally what you're burning. In this case, what we have is these cores are solid, and then we're putting oxygen through them, which is a liquid, and they react together. And the benefits of that is that it's much more stable. It's like liquids, they're very hard to work with because you have to keep them super cold. And the problem with solid motors is that once you get them going, you can't stop them. So what we do is we combine the stability of a solid rocket motor with the ability to throttle of a liquid, and it produces a very useful engine.
And very safe.
All right,
Very
that's
safe.
what we want, the safety. Well, it looks like we aren't having anybody answer our brain teaser, and so gosh darn, I need to have it thrown up again to get the numbers if you don't mind. All right, so John bowled games of 105 and 190, and he wanted an average of 150. So he bowled 105, 190, and we wanted an average of 150. Well, stop and think how would you think about doing that? Well, he's going to bowl 3 games. So he did bowl this one, he did bowl this one, and we don't know that one, right? We don't know that one, but we know this is going to be an average. So we have to stop and think how we find an average. Remember, boys and girls, the way you average is you add up all the numbers, and then you divide by how many numbers you added. So, gosh, that means I'm going to divide this by 3 because I have 3 numbers, even though I don't know my box yet, do I? All right, well, you know what? I think I'll add these 2 first. So I have 105 and I have 190. I'm going to line them up by place value. 1s plus 1s, 10s plus 10s, 100s plus 100s. So now I know that I have 295 plus my secret bowling one divided by 3 is going to be 150. Well, you know what? That kind of looks like a fraction, and I know boys and girls don't like fractions. So let's undo division by multiplying by 3 on each side. So 295 plus our box is going to equal 450. Well, we want to find box. It's tied up by addition, so we'll undo that by subtracting on each side. And so our box is going to be 10 take away 5, 14 take away 9, 3 take away 2. Oh, it's possible to get that average then by a 155. And the way you can check it is add all these, divide by 3, and guess what? It should end up to be 150. So, boy, let's make sure that we stop and think. I think you can do these brain teasers. I'm trying not to make them too hard for you. Let's challenge you a little bit, right? And hopefully you learned a way to do this, okay? So next time when we have a brain teaser, you can call in and get the right answer. All right. So Tom, if you want to have another question for our good Air Force Academy cadets.
All right, so nobody's shooting off the rocket from home. They didn't win the rocket, but you guys are shooting Colorado Science Carnival, October 23rd?
24th, yes.
24th, October 24th.
But matter of fact, we do have a thruster we can fire
We
here
have-
today.
Oh, okay, let's do that.
All right, Sean?
Yeah,
Yes.
yeah, it's going to have to be quick.
No
We're
problem.
running out of time.
This is our pulsed plasma thruster. It is a thruster we use on our spacecraft to adjust their attitude, where they're pointed. So, go ahead.
Jump, jump, jump. Sounds like someone on the 4th of July.
You see, it's just a small little pop, and what it is a copper tube with Teflon inside. We energize the Teflon with a capacitor. It vaporizes and shoots the Teflon out in a plasma form. So it's so hot that it actually becomes plasma. This we can use, even though it's a small little pop, it's 10 micronewtons. Very, very small force. But you can still use it to change how you're pointed in space.
Interesting.
Very interesting. Well, we want to thank you so much because we're getting to the end of our show. So we want to thank you for sharing. Don't forget the 24th, and it's nice to meet you, Sean and Winston.
Man, that's
Bye. See you on
Have a great
Monday.
night.
See you.
This year, Parkview Medical Center was awarded Best Hospital in Southern Colorado. 3 cheers to our incredible staff for exceeding patient expectations and excellence in care. Parkview Medical Center, caring for you.